Good afternoon, everybody, and welcome to another Prokon Know-How episode. In this episode, we'll be dealing with a column design link error. So this is something I find that it's an issue that pops up quite frequently, and that's it when you've analyzed your structure, your model in Sumo, and you want to export concrete columns to the column design module. So that's either rectangular column or circular column, then you might get an error. So let's jump straight into it. So you've got quite a large model, sorry, not module, but model, and you've got quite a large number of columns. And what happens is that you might put in some wind loads, some lateral loads on that column for one, and then you've run your analysis. So it won't show the error now, but once you try to export using the design link, you might come across an error. So I'm going to export that column. This column just says warning, one column or columns are loaded in span. Note that the design link only transfers in moments. Do you want to ignore the warning, export these columns anyway? Okay, so what's going to happen in this circumstance is that that UDL is going to be converted into a moment at either the top or the bottom of the column. Okay, so that is taken into consideration just so that you know. All right, so just so that you know, this is then converted to a bending moment at either the top or the bottom of the column. In the case where you might have some stiffener beams or braces or whatever it might be, and you try to export that column, this is where the main error will pop up. So I go to column. As I click on that column and I press enter, you see error. One column or columns were discarded due to connections along the height. And that's because of this beam coming in at the side. Because the program works within connection, or rather the design code works within connections only, your rectangular column cannot make use of this column. Okay, or recol cannot make use of this column. So how do you fix that? Well, you'll need to split that column in half. So in this case, it's a 3.8 column. So if we go 3.8 divided by half, we're sitting at 1.9. We can copy the column upwards. All right. We just need to run our analysis again. And then you can export this column now. You know that what counts for the one will count for the other. So if we look at results and go to beams, we can see we have a consistent axial force. So if I switch input on, you can see there's that column. So it's still split. Oh, sorry. There's that column. It's still split, but we pretty much have a uniform axial force. In this case, the one at the bottom is slightly larger, just due to the self-weight, well, most likely due to the self-weight of the column section above. And then what you can do, of course, you're just going to export the bottom section using the design link, because you know that's going to be the critical section. So you just go to recall, select that column, press enter, and you can design. And you know that you're just going to apply this effect along the whole length of the column. All right, and that's basically how you resolve that issue. I hope that that helps you out a bit. I hope that it solves quite a bit of frustration for you as well. And then if you have any questions, please pop them in the comment section. If you found this video useful, just hit it with a thumbs up and don't forget to subscribe as well. And then I'll check you in our future sessions. Thank you so much for tuning in.